Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. For tonight, we're going to take a look at promoting productive struggle with TI Technology. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited to introduce our two panelists for tonight, Sam Goff and Michelle Reinhardt. Sam is in his 16th year of teaching mathematics at the Westminster School in Atlanta, Georgia. He has been a part of the T-Cubed family since its beginnings, and as a national T-Cubed instructor, he has helped write numerous activities, workshops, and books, as well as lead numerous workshops and present at various conferences. Sam lives in Marietta, Georgia, with his wife, Jill, who is also a T-Cubed national instructor, as well as his daughter, Annie, a 7th grader. Sam, thanks so much for joining us tonight.
Glad to be here.
And born and raised in rural Ontario, Michelle studied mathematics, physics, and education before moving to Texas. Michelle has taught high school math and science at rural districts in Texas, while also working as a math and science consultant throughout the state. Her interests include technology integration, conceptual understanding, and curriculum and instruction. Michelle, so glad to have you with us tonight.
Thanks, Mike. Glad to be here.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions you have for Sam or Michelle using the Q&A window on the right side of your screen. As a reminder, we'll be sending a link for the certificate as well as a link for the documents at the conclusion of the webinar. And this webinar is being recorded. You'll automatically receive a follow-up email with a link to that recording. We hope you don't have any audio issues, but in the event that you do, in the participant window, find the icon that looks like a phone. By clicking that icon, you'll receive call-in information, which will let you call in using a phone, and that should alleviate any further audio issues if you do have them. At this point, Sam is going to discuss our agenda.
Well, good evening. Glad to be here with each of you. I'm new to this, so bear with me. So our agenda tonight, we're going to start with a brief introduction to what we think productive struggle means. We're going to do various activities, one of which is called Which One Doesn't Belong. We're going to construct a viable argument. Michelle will go a little bit deeper into what the verbiage around destructive and productive struggle are. And then another neat activity about notice and note that can be used in lots of different areas. And then I'll sort of finish up the activities with another one where we'll look for and express regularity and repeated reasoning. And finally, we'll look at some student and teacher actions for productive struggle.
Thanks so much, Sam, and be sure to stick around to the end, because tonight we're going to be giving away to one lucky winner a T-Cubed International Conference registration for 2 to the upcoming T-Cubed International Conference in San Antonio in just a few weeks, March 2nd to the 4th. And Michelle, would you mind talking through some of our expected outcomes?
Absolutely. So by the end of this hour together, during this time, we will explore how TI technology can be used to promote productive struggle. Also a lot of teacher and student moves that support that work as well. We'll also discuss and model some different tasks and instructional approaches that promote opportunities for students to engage in productive struggle. And throughout this, we'll highlight how students can solve tasks and use multiple representations to deepen their mathematical understanding. So a lot of kind of interwoven ideas that'll kind of permeate throughout our hour together, and lots of opportunities for y'all to share some of your thinking about these ideas in the chat as well.
Michelle, thanks so much. Sam, you have control. Feel free to share your screen. It's all yours.
All right, great. So let's start with just a kind of a brief idea of what productive struggle is about. And a lot of this is based upon the mathematics teachers' practices from the NCTM's Principle to Actions, as well as some of the math practices that we'd like for our students to engage in as well. A lot of the activities focus on how we can use visualization as well as conceptual development to help students think deeply about mathematics ideas, and relationships. So one of the definitions that I like, it comes from John Hattie, who wrote the book about visible learning, that states that the principle of productive struggle is that students who confront and fail a challenging problem are then provided further clarifying instruction, outperform traditionally taught students. So simply put, yes.
Sorry to interrupt you. Do you want to be sharing your screen at this point, or are you okay?
Oh, I'm sorry. I'm sorry. As
That's
I said, I'm new to this, so bear with me.
You're doing great, Sam. No worries.
Okay.
Thanks so much.
How does that look better?
Yes,
it definitely does.
Okay, so here's our John Hattie's sort of definition of productive struggle. And I think that the key here is how do we provide further clarifying instruction without giving away sort of what we want students to get to. So I like also what Jo Boaler says. I've watched her a couple times, and I'm real fascinated by what she has to say. And she talks about when students make a mistake in math, they actually grow a synapse. She's very profound about talking about how students actually learn more when they make mistakes rather than when they're successful. So not allowing students to make mistakes is one of the things that prohibits sometimes kids from moving ahead, moving forward in their own learning. So we ask the questions, how do we provide for students ways in something called slow math? How do we give them opportunities to notice and note? How do we give them the time, the opportunities to move forward in their own thinking at their own pace? How do activities provide for visualization and conceptual development of mathematics that help students think deeply about mathematical ideas and relationships rather than just sort of that, hey, here's a formula I need to memorize it. Let me just learn those formulas and I'll be great for the test and not really know what's going on. So our learning intentions for this evening, and we hope that we'll get through most of these, is that I can invoke slow math to engage in productive struggle to show what I know in more than one way. So even if these activities you see, hey, I got the answer, can you do it a different way? Can you do it a third way? Can you do it a fourth way? I can recognize the difference between productive struggle and destructive struggle. When you see our kids in our room, are they being productive or are they moving in the wrong direction? And what can we do to, as Tim Canel says so eloquently, to unstuck students? That's a Tim phrase, not a my phrase. And then lastly, can we anticipate how students will solve tasks and expect them to use multiple representations to deepen mathematical understanding? So in the NCTM's Principles to Actions, there are 8 mathematics teaching practices that are similar to the 8 mathematical student practices. And number 7 is the one that we're kind of focusing on tonight. How do we support productive struggle in learning math? In Praise of Slowness by Carl Hornarek, it is a cultural revolution against the notion that faster is always better. And in a lot of times in math, in the middle school, early schools, even in the upper schools, we are so bent on students doing things in a fast way. And it's, as he says, it's about seeking to do everything at the right speed, savoring the hours and minutes rather than just counting them, doing everything as well as possible instead of as fast as possible. It's about quality over quantity and everything from work to food to parenting. And I know that the first thing that most people say when they see that is, well, I have to cover all this content. And I have become to believe more and more that less content but done deeper basically benefits the kids. So our first activity will be led by Michelle. So Michelle, I'll turn it over to you.
Thanks, Sam, for setting the stage like that. So for this first task, we're going to work on our mathematical flexibility to show what we know in more than one way and to make connections between different lines of thinking. So let's consider the 4 graphs shown here. I'd like all of us to take a minute to consider for ourselves which of these graphs doesn't belong, and more importantly, why. So let's give everyone some time to think about their response on their own. What would your response be to which one of these graphs doesn't belong and why? And let's keep in mind what Sam kind of set us up for and discussed about slow math, about valuing quality over quantity and or speed. Now, as you're thinking through this, if you will, can you please share your thinking in the chat? Specifically, will you share about which graph doesn't belong and why? And as we do this, it might be helpful to refer to the graphs using labels such as the upper left or the lower right, so that we're all clear on what graph you're describing. So let's take a couple minutes and share our thinking in the chat about which graph doesn't belong and why. And as you're sharing in the chat, also be sharing or be reading through some of the other reasons that you're seeing from others in the community. And also, let's purposefully work on our mathematical flexibility. So you may have explained a reason why one of the graphs doesn't belong, but now challenge yourself to explain a mathematical reason why each graph does not belong with the other three. You could also consider, can you determine more than one mathematical reason why each graph does not belong with the other three? So let's take a few minutes to work on our collective mathematical flexibility in the chat by sharing our ideas and also reading the ideas of our colleagues. So some of the thinking that I'm seeing so far, and please feel free to keep sharing your thinking in the chat. I'm seeing a couple of people have shared about how the graph in the upper left is not linear. Others have said that the graph in the upper left is curved and the others are all straight lines. Others have said the graph in the upper left is the only one that decreases and increases over its graph instead of just doing one of those two things. So we could kind of look at each of those reasons and consider which ones are perhaps visual reasons and which ones are mathematical reasons. What additional language might we overlay on some of those ideas as well? So that's just for one of the graphs. Let's keep sharing and keep thinking about, can we come up with a reason why each of the four graphs, I guess there's three left we haven't talked about, doesn't belong with the others. So Sam, feel free to jump in here too on anything you see. Let's talk about maybe the upper right. I'm seeing a comment about the graph in the upper right is the only one that has no values in the first quadrant. That's interesting. I wonder if there's any other mathematical explanations for why the graph in the top right does not belong. I'm seeing one from Melanie earlier who said the top right because the domain of this graph is different from the others. That's interesting, and I wonder if reading and hearing Melanie's thought helps us notice something that we maybe didn't notice earlier. Moving on to the graph in the bottom right, I see some people noting that the bottom right does not have a decreasing portion, and it's the only one that doesn't. I think someone else said this in a different way when they said that it would be the only one whose derivative was not negative for any values. So that's interesting how we could have two related mathematical ideas that might be phrased differently at different grade levels. Also, somebody noted that the bottom right graph has a different range than the other three graphs. That's interesting. So thank y'all so much for the diversity of mathematical thought that is showing up in the chat. I love which one doesn't belong for many reasons, but this is one of them, this idea of how everyone can kind of jump in and access the task, but we can all learn from each other's thinking as well. Lots of opportunities to notice different things, and or maybe notice the same thing, but explain it using different vocabulary and thinking about the learning opportunities that that provides. So before we move on from this particular task, I'd like us to kind of step back out of it for just a second and consider one final question. So how specifically does a which one doesn't belong type activity support productive struggle? And we may or may not answer this question now. If you have some thoughts on it, please feel free to share them in the chat. The question again is, how does a which one doesn't belong activity support productive struggle? But that's going to be kind of a common theme we'll think about throughout the webinar and then revisit at the end about how do these particular instructional approaches, whether it's a which one doesn't belong or as Sam will take us through next, focusing on constructing a viable argument, how do these instructional moves specifically create instances that support students in productive struggle? Sam, let's move to our next task, and at the end, we'll kind of bring all these tasks together to consider the full landscape of the experience.
Okay. So one of the things that I look a lot at is the standards for mathematical practice. I'm not a school that does that we just do our own different content, but I certainly think that the standard mathematical practices have a lot of validity and have a lot of usefulness. And one of them is I can construct a viable argument and critique the reasoning of others. And what you're looking here is a learning progression that was created by Jill Goff, yes, she's related, and Jennifer Wilson. The different levels, level 3, if you look at these, are always where you want to get students, but these are written with the mindset to how do we help kids move from the level 1 to level 2 to level 3, etc., and then beyond. Level 3 is acceptable, level 4 is going above and beyond. So you can take a second there to read what these are, and when we're talking about it, constructing a viable argument and critique the reasoning of others, how do we show this in such a way that the reader of the problem doesn't have to ask any questions, that they can look at it and know without doing anything what the solution is and what the reasoning is behind the solution that's chosen? So the other one that kind of goes along with, oh, I guess it wasn't here. But so the question that I want you to consider is this one, and a very common misconception that students have. How might we guide learners to construct a viable argument to deepen understanding of this concept that connects symbols to graphs, to a table, to a concrete model, and a written one? What does it mean to construct a viable argument? And I know that we're in a chat room and you can't really show what, but I want you to take a few minutes and think to yourselves or write it out on the side how you might do this. And then I'll ask for some feedback in the chat, some different ways and different solutions that some of you may have gone about to produce this argument. So I will shut up and let you do a little slow math and see what you can come up with.
And Sam, while everyone's kind of thinking, I just want to add in that maybe other teachers have the same feelings that I do. Getting your students to critique the reasoning of others in a polite, efficient, accurate manner is something that I have to teach my students. They don't usually just come walk into my room able to do that. And that just by itself is its own challenge. And then there's the idea of talking about math and critiquing other people's work in math. That is another layer too. So I just wanted to add that.
Good.
I love that, Mike, because that connects to John Hattie's book talks about the importance of teaching, having social learning intentions as well. So not just content learning intentions, but also what kind of social skills around our discipline should we be teaching students, like how to, politely critique the reasoning of others. Love that connection.
Dylan Willem also talks about that in one of his chapters in Embedding Formative Assessment, is how do we activate students as learners for their peers, how, as teachers for their peers, how do we help them do that efficiently, effectively, without, as Mike said, without being mean or rude or that sort of thing. As I see the chat box, we've got lots of good ideas popping up, so take a look as you see some different things popping up. So some of the key things that we're seeing, of course, is technology. I've seen some tables mentioned. I've seen area models mentioned. What else have I missed? I see tables, manipulatives I've also seen. Substitute one value.
About plugging in values, about drawing arrays or using the box method, kind of two names for something similar. Graphing two of the functions. It's so interesting because I think each of us had kind of a go-to first idea of what we would do, but those ideas were very different. We've got this, again, this diversity of thought about how we might approach this.
And again, if you found one way, jump in and find another way. I noticed one participant was talking about if they're trying to substitute in a number and if it's 0, hey, it works. So you might have to encourage that students to try, and there's another one mentioning that, you better try something different than 0.
So just substituting in a value doesn't necessarily make it true. That's interesting.
And that's a good one.
I'm also seeing someone think about kind of the left expression and the right expression, but through the lens of transformations, like what transformation that would look like on a graph. So that's interesting too.
Right, start with x squared and what does the left do, what does the right do?
Yes, sir.
All right, so just real quickly, a couple of things here. If I look at this on a TI-Nspire file for just a second. So one of the things that we certainly would like for students to do is see this visually. So how does the TI-Nspire help us do that? Well, clearly, as someone mentioned, we can start by just looking at the graph of x squared plus 1, as well as the graph of x plus 1 raised to the second, and we clearly have a pretty good argument. If you look at those two, clearly they're not equal. We can talk about, as someone mentioned, that the red graph has been translated to the left 1, whereas the blue graph has been translated up 1. We could also add a table, and we could talk about, if we look at this table of values, we clearly are not getting the same numbers for different values, except for that lone value of 0. If I can get up to that number. We clearly at 0, we do indeed get the same value, but that's certainly the only number that we're going to get the same outputs for the given input. We could also consider creating a trace feature of this by looking at, and I like the one in this particular case where we trace all, and we can begin to see both outputs and clearly see that at any given output except at 0, the outputs are different for each given input. So we clearly have a pretty good indication that these two functions indeed are different. And again, the point of this is not necessarily that we are proving it to ourselves, but how would a student prove it to another student? How would they write something down and show another student who would believe that this is a true statement without having to ask any questions? If I look at this solution, here's a nice little document that shows you a bunch of different solutions. Again, Jill put these together. You can see you can use a graph, you can use a table, you can use a valuation, and here's the one that I think a few people mentioned, that if you plug in 0, you indeed get the same number. So let's check it one more value to make sure. We could try different values. We could do some foiling. Here's an area model. So yes, indeed, there are lots of different ways that we could show and prove multiple representations of how this is true. So again, we're trying to get students to say, we can do this with graphs, we can do this with tables, we can do this with area models, we can do this with evaluations. And if a student produces one of these and then shows another student, can we get them to do another one and another one and another one till they really begin to think about multiple ways to solve different problems. So I think that's it for that one, and that's how we would think about constructing a viable argument, trying to look at the math practices. If I went back for just a second while we're here, think about where these are. Construct a value. If I look at level 3, construct a viable argument and critique the reasoning of others. And then level 4 is that one that tries to get kids to go beyond that. Can you build on the viable arguments of others and use their critique and feedback to improve my understanding of the solutions to a task? I think I see too often my students are happy they got the answer, they lean back in their chair, they're done. And, you know, how can I help those students say, let's look for something else, let's look for something different, let's turn to our partners and see what they're doing, and can you help them, critique them, give them a little bit of feedback. So that takes care of that. So let's move on to, I think Michelle's going to pick up with this one and talk a little bit about some of the verbiage that is associated with destructive and productive struggle. Michelle.
Yeah, Sam, do you mind going back 2 slides for just a second? Because something you just said kind of triggered something for me when you're talking about kind of taking the feedback. So just stop right here.
Sorry.
That's okay. Forward one more to Jill's diagram. So say I'd constructed a viable argument using the fact that perhaps the tables don't give the same output. So I know the tables are kind of small in this image, but you can kind of follow along with the thinking. And someone kind of responded back with, well, what would it take? What would it take to make those 2 functions have the same output? And so one thing that Jill actually explored in her argument here was she'd graphed, or she had a table for x squared plus 1, and then also for 2x, and how adding on that 2x to the x squared plus 1 column does produce the same output as the quantity x plus 1 all squared. So that's a great example of that idea of not just creating a viable argument, but then taking the feedback and questions you get from a reader and really using that to enhance your viable argument and think more deeply about it. So love this idea about how can we have students construct viable arguments, especially for ideas related to common misconceptions, but doing so using multiple representations really pushes their thinking. So thanks for sharing that, Sam. I love this. Every time I see this, I think about this in another way.
Oh, you got building alarm there going?
I was going to say that's absolutely an alarm here at the building. But
so before she jumps in there, this is another one that Jill created. This is not a standard mathematical practice, but we love love to talk about this in my room, is to talk about how we can apply flexibility so what you know more than one way. So again, if you look at level 1, it's simply I can find a solution. This is what my students do. They kind of stop and I say, okay, well, if you found one way, can we find another way? If you found another way, can you find a third way, etc. So this is actually a poster that I try to use in my room and try to encourage students to not be satisfied with looking at things one way, but can they see it another way? Not a standard mathematical practice, but one that I think is well worth thinking about in your own room. Okay, so you ready to do a little destructive and productive struggle?
Yes, sir. My colleagues are working on the building alarm, so hopefully that's not terribly distracting. But if it is, you can just jump in, Sam, and kind of talk through some of this part where they're getting that fixed up. So what I'd like us to think about is, in light of the activities we've worked and learned through so far, to consider 2 types of struggle, specifically destructive struggle and productive struggle. And so I'd like you to think for a minute about a time when you or one of your students have been in destructive struggle. And I'd like you to think about that and think about how you would describe what destructive struggle looks like, feels like, sounds like. So take a minute or 2 and share some of your thinking in the chat about what it looks like or feels like or sounds like for you or your students to be in destructive struggle. I'm going to mute for a second while we work on the alarm.
So feel free.
Share some of your, sorry, go ahead, Sam.
No, I was just going to suggest folks can be adding things to the chat as they think through them, but again, we're not in any hurry.
That's right. Oh my gosh, I can like feel the destructive struggle from some of the comments. These are great. So being overwhelmed, feeling like they don't have and won't ever have the skills they need to be successful, having no entry to even get started in something, being frustrated. Frustration in all caps, shouting frustration, yes, I like that. No advancing questions, feeling like the math is out of reach, feeling like all you can do is give up. Not having a clue, having no idea how to start, and then moving to off-task behavior because of all of those things. More shouting, I quit, I can't do this. Yeah, so just reading these ideas, I mean, we've all either experienced them to a certain degree with some kind of task in everyday life and or in mathematics or had students experience these. So these are great kind of descriptions of what it feels like to be in destructive struggle. And you can kind of just feel kind of the negativity around that. So if you'll kind of push pause on your thoughts about destructive struggle, and let's switch gears here a little bit. So let's think about, instead, let's consider a very different kind of struggle. Instead, think about productive struggle. So think about a time when you or one of your students have been in productive struggle. And how would we describe what productive struggle looks like, feels like, sounds like? So think about this for a minute. Again, a time when you and or your students were in productive struggle. What did that look like, feel like, sound like? And share some of your thinking in the chat for us to see all together. So feel free to keep sharing, and I'm going to narrate some of these into the webinar as well. So comments like, I have an idea. Hey, let's try this. A willingness to keep on trying, persistence, a belief in yourself that we just haven't gotten it yet. And now we're shouting yet. Intermediate progress, having an insight. Hey, could I do it this way? Keeping at it. Something's on the tip of your tongue. You've got an idea that's coming. Students are engaged and still trying. Students are exploring. They feel like they have something to contribute. Asking questions like, hey, how did you get that? Trying to kind of make sense of what's going on. Here's a good one. This isn't as bad as it looks. Some of these strategies that kind of help students overcome learned helplessness. Someone's describing the light bulb effect, the aha moment, keeping trying, perseverance. Hey, why does that work? Feeding off the ideas of others and regrouping and trying again. And I'd like us to just consider, having narrated out the destructive struggle comments and now the productive struggle comments, how those make us feel, right? Even as educators in this moment, just reading them and hearing them out loud, kind of the air around destructive struggle and then the completely different air around productive struggle. So thank y'all so much for sharing your ideas in the chat. Feel free to share other kind of examples and ideas about what productive struggle sounds like, looks like, feels like. And I think that our descriptions here are a wonderful testament to the fact that not all struggle is created equal. So I'm going to say that again. Not all struggle is created equal. And our goal as teachers should not be to remove all struggle for our learners, but rather to create and foster learning experiences that help students experience and move through and learn through productive struggle. So Sam, if you'll go to the next slide, we're going to share a chart from Robin Jackson's book, How to Support Struggling Students. And in this book, it offers a wonderful summary of the differences between destructive and productive struggle. So I'll give you a minute to kind of just glance through and read through some of the ideas on this chart. And I'd like you to consider how these ideas align with the descriptions that we just shared in the chat. And y'all, seriously, I feel like y'all just kind of narrated this chart out with all of your observations and descriptions of what destructive and productive struggle look like and feel like in the classroom. And this chart just kind of gives verbiage around many of those same ideas. And so some of my favorite are about how productive struggle leads students to feelings of empowerment and efficacy with the sense of hope that they too can access this mathematics and these big ideas. So this is one of our favorite kind of checkpoints about the difference between destructive struggle and productive struggle. And again, really kind of highlighting this idea that not all struggle is created equal. So if we are to help students sustain productive struggle, we must be able to recognize both productive struggle and destructive struggle and support moving our students out of destructive struggle by using the art of questioning. And Sam and I are going to model some of that in the next few activities. So we want to think about how can we recognize when students are having the flow of productive struggle. That's something that many of you talked about in the chat. And when students don't, when students aren't in productive struggle, or even when they are, when we can use ask, don't tell prompting to help students become unstuck. So how we can ask questions instead of rushing in to tell a next step or an idea. So we can also consider what are kind of some key indicators of destructive struggle and what teacher or student moves can move a learner back into productive struggle, back kind of onto the learning trajectory. So let's keep these questions in mind as we kind of move into the next few activities. So Sam, I think we're ready to move into our next piece where we're going to look at noticing and noting, and you're so I think we can jump over to the TNS file for that. So while Sam moves us over, I'll talk a little bit about what notice and note is. This will be our next kind of instructional approach that we'll look at. Our English language arts counterparts use a strategy called notice and note to help students read and comment on and learn from really complex text. And so we're going to practice notice and note here in mathematics, along with I can look for and express regularity with repeated reasoning. So we might first consider, like, what does it even mean to look for and express regularity and repeated reasoning? And Sam kind of has this graphic here about that, but I'll just kind of summarize it with one sentence, which means that to look for and express regularity and repeated reasoning often means paying attention to what changes and what stays the same. And so we're going to practice that with this TNS file that Sam's pulling up. So Sam's going to go ahead and take an action on an object in this file, and I want you to notice what changes and what stays the same while he moves point P around. So again, what changes and what stays the same? What do you notice? So I wonder what you could note about what you have noticed so far. So take a minute or two to note and share your noticings in the chat. So if you'll kind of move over to the chat and share, note your noticings to the whole group. So I'm seeing that some are noting that the hypotenuse stays the same, and some have added a little bit more to that, saying that the hypotenuse maintains a length of 5. I'm noticing some people noting that the leg lengths are changing, but that there's also always a right angle and or a right triangle showing
Is
up.
it?
Ooh, that's interesting. Almost always a right angle or a right triangle showing up. That's interesting. As one leg gets shorter, the other gets longer. So what else do we notice? And we might also wonder what has to be true for the different objects we've been describing so far. So we've noticed a change in the two legs, but no change in the hypotenuse. And what has to be true for these kind of 3 segments? Yeah, so as one side increases, the other side decreases, and then we could dig kind of deeper into that and think about, is there another way we can kind of quantify and or describe the relationship between those sides? We could also think about how the lengths of the legs relate to point P, if at all. So how do those leg lengths relate to point P? I'm also seeing some discussion in your noticings as I kind of scroll back through them that some of y'all have noticed and noted some Pythagorean theorem relationships between the legs and the hypotenuse of that triangle. So that's kind of interesting. I'm noticing now that some of you are noting that the lengths of the legs are the coordinates of point P. That horizontal leg is perhaps the horizontal coordinate, and that vertical leg is perhaps the vertical coordinate of point P. Interesting.
But is that true in all quadrants?
Interesting. Or would we have to account for that? That would be the magnitude of those coordinates. Would we have to look at signs differently? So again, in kind of a live setting when we're all together in a room, this discussion would unfold a little bit differently, but we're trying to kind of pull some different ideas from the chat as we're doing this in a webinar format as well. And so we might have some ideas here about what happens. Like I've noticed a couple people talking about circles, which I am like not seeing in this image. Like I'm seeing lots of right triangles, and then Sam keeps bringing me back to those counter examples of just line segments, but I'm not seeing circles. And so we might explore that a little bit further and actually maybe trace out the path of point P to create a visual to support some of the ideas that some of y'all are seeing and maybe make that a little bit more explicit. So Sam's actually tracing out the path of point P now as he kind of moves that around the coordinate plane. And we might think about how this path connects to all the ideas that we've seen before. So since the hypotenuse stayed constant, that would be the radius of the circle that point P is kind of tracing out. Yep, someone's mentioning it's a circle with radius 5. This connects back to some trig ideas related to circles and right triangles. And then we can kind of develop this idea of like, how would we actually write an equation that represents all of these points and everything that's true about them and the path that P travels. So lots that we can kind of explore there as we work to kind of make sense of what's going on and how triangles, right triangles, are connected to circles of all things. So it's really interesting. And Sam, if you don't mind maybe moving us forward over the next 2 pages, and if you'll just maybe kind of explore the next 2 pages a little bit, Sam. And as we glance at these next 2 pages, Sam's going to just model some of the functionality of this page and the next page, but we could consider, like, how might these pages build on what we just looked at, and how might these pages support students' productive struggle while they explore and make sense of the equation of a circle. We might also consider what might students notice and note on these pages about what's changing and what's staying the same. So this is one page that they can explore. And Sam, if you don't mind going to page 1.3 for just a second. And again, same kind of questions to think about like how could this page help students make sense of the equations of a circle? What might they notice and note? And how might this support their productive struggle about what it means to model an equation of a circle? So we won't spend a bunch more time here because we have another activity we'd love to get to. But what we really want to kind of draw out from this piece is considering the pedagogical approach of having students notice and note about dynamic mathematical visuals, like we did here, and considering how might notice and note impact engaging students in productive struggle. So this is another powerful instructional strategy for having students think deeply about mathematics without first rushing in to tell students the math. Sam is going to lead us through another activity that uses instructional approaches that continue to support productive struggle next.
Yeah, and it's continuation of this idea, and again go back to what Michelle said. If you look at level 1, notice and note what changes and what stays the same. That's level 1, and how often do we get kids to look at things and say what's changing, what's staying the same, and then can I just start looking at patterns? So the next activity that we have is another TNS file that I think Jennifer Wilson wrote that's called What's My Rule? And we're going to do a couple of these, and again, we're getting a little tight on time, so we'll go through this a little bit faster. But the key idea here is you notice you've got two ordered pairs. One is point Z and one is point W. And as I change point Z, what happens? So I'll just let you look at that for just a second. And some of the things that we begin to ask students is what happens when Z is on the x-axis? Positive x-axis. What happens when it's on the negative side of the x-axis? What happens if it's on the y-axis? What happens when it's in different quadrants? If it's in quadrant 1, where's W? When it's in quadrant 2, where's W? So if kids are stuck, these are kind of questions that you begin to look at and say, what is it that I can ask my student to unstuck them? And the second thing would be here, if you look at, and I see somebody mentioning reflections, is can students start thinking about these in more than one way? Because the simplest answer is very simply, I'll give you the easy one, right? It's just negative x, negative y. But what are some other good things that we can say here as I look? I see symmetric with the origin. We could talk about symmetry. I saw that, and there's a couple of different symmetries going on, correct? We could do the x, then the y, or we could do the y and then the x, which means that those 2 points, and I think I saw that somewhere, where it's a odd function, so or odd. Well, I guess it is a function. So you're doing all those things and seeing all those relationships. You could also think of it from a geometry standpoint. What kind of rotations are happening here? How would you rotate point Z to point W?
I love some of the moves that you made there too, Sam, about like when you were moving it around, if I wasn't kind of explicitly noticing some of what was going on, kind of being purposeful about stopping on different points or going to kind of friendly points, quote unquote, to maybe help me notice other things that I'd missed previously. Those were some nice moves.
And I see someone says a 180 rotation, and it actually can be a 180 rotation in two different directions. You could rotate it clockwise or counterclockwise. So I want to show you one more, and again, time is starting to get tight here, but this is one that's a little tougher. I've already got a grid on it. I didn't mean to have the grid on, but that's okay. So if I move this point around, what kind of things do you notice? And the key here, if you have a problem like that that's a little bit tougher, is to get students to start saying, what you can do as a teacher, what teacher move can you do to start helping kids become unstuck? So let me just move it for a little bit and see if you kind of see anything. So it might be important to see what happens when it's on the positive axis, what happens when it's on the negative side of on the negative values of the x-axis, what happens if it's in different quadrants. Does it matter if x is positive? Does it matter if y is positive or negative? Does it matter, here's x being positive or negative? Does that matter? Does that change things? So somebody has already noticed something pretty important, that the y value always stays the same. So what is the mathematical relationship between these two things? W is the z distance from the origin, okay? So what do I do if kids get stuck? Well, here's a couple things that you might consider. We could change these numbers to integers and start helping them because there's too much sort of stuff going on. Now, the problem with moving one integer is I still can't, the first time I move this, that jumps away. Well, there's a feature in here that where I can redefine this point to be on the grid. And now what these points will stay is integers, at least Z does. And if I happen to hit some nice numbers like, ooh, that one, or what else do I need? Like that one, I can suddenly begin to see some things that maybe help students make sense of that. Look, if I'm at 4 or -4, I get the same number. If I'm at -4 or 4, I get the same number. And then one last trick, again, to helping kids to get unstuck, is can I actually draw a circle that would be from this point to this point, and notice that, as someone has already pointed out, W represents the distance that Z is from the origin. So in other words, it solves the Pythagorean triple. So the idea here is not necessarily, and I know it got rushed there at the end, but what we really want students to begin to think is notice and note. And more importantly there is how can we help students, what can we help students see the right questions? Ask, don't tell. So that's it for me, and I think we're done with that activity. And Michelle, do you want to take a minute? I think we're getting tight, but do you want to take a minute to try to wrap up with that other document?
Yes, thank you. And thanks, Sam, for kind of modeling some of that thinking there too, or different moves that we can do, things like adding the grid, moving to points that make some of the relationships maybe a bit more explicit, et cetera. So as we begin to wrap up for the evening, I'd like us to consider this document, and I'm going to go ahead and share a link to it in the chat as well. And this comes from NCTM, and it's publicly available on their website, and it's a document listing teacher and student actions that support productive struggle. So I'd like us to consider our learning experiences together this evening and consider them in light of this document that Sam's kind of showcasing here and that's linked in the chat. And I'd like us to think about, where did you see or experience specific examples of these teacher and or student actions that support productive struggle? So feel free to take a minute to share some examples, including specific moments or teacher moves in the chat, and I'll narrate some of those teacher and student actions as well. So some of the teacher actions are things like giving students time to struggle with tasks and asking questions that scaffold students' thinking without stepping in to do the work for them, or helping students realize that confusion and errors are a natural part of learning by facilitating discussions on mistakes, misconceptions, or struggles. Praising students for their efforts in making sense of mathematical ideas and perseverance in reasoning through problems. Some of the student moves involve asking questions that are related to the sources of their struggles and will help them make progress, persevering in solving problems, and realizing when it's acceptable to say, I don't know how to proceed here, but not acceptable to give up. So love these kind of ideas about framing teacher moves and student moves related to productive struggle. I'll also have us consider some of the instructional approaches that we highlighted tonight. So here's kind of a quick list of some of the things that we did, looking at which one doesn't belong in mathematical flexibility, constructing a viable argument and focusing on multiple representations. We've done a lot of noticing and noting with dynamic mathematical visuals to give students an opportunity to engage in slow math, to notice and question. Also looking for and expressing regularity in repeated reasoning, and deliberately asking questions to unstuck, quote unquote, students without taking over the thinking for them. So as we kind of wrap up, you might want to consider what teacher actions from our time together really resonate with you as key moves that support productive struggle. So thank you all for sharing in our learning community this evening, for making your thinking and your struggle visible, and for contributing to this collective conversation about how we can move student learning forward through productive struggle. Thanks for showcasing and discussing student and teacher moves that support this critical part of learning. And Mike, I think that wraps up the parts that we have, but I know you have a fun draw to wrap us up and some announcements here at the end as well.
I do. Thanks so much, Michelle and Sam, for sharing everything that you did. Sam, I'm going to take things back if it's okay with you.
Say again?
I was going to take control back if it's okay with you.
I'm trying to do that.
I got it. Thanks so much. So I do want to share one thing that sort of popped in my head tonight as Michelle and Sam were talking about productive struggle, and that is on our website, education.ti.com. Under the Activities tab, so let me try that one more time. There we go. Under the Activities tab, take a look at the building concepts in mathematics, and I can just speak from one really quick anecdote. This is probably a year, maybe even 2 years ago now. I distinctly remember, Michelle, you were presenting to a group of people, and I happened to be in that group, about ratios and proportional relationships, and something that I felt like I had a really good handle on. And then you started asking questions, and you started asking us to explore certain relationships and to wonder, and I walked out of there, out of your session thinking, gee, I probably need to look at that again. So my point is that I think a lot of these specifically building concepts files, you'll find your students engaging in productive struggle. So if you're looking for some areas where you could automatically tomorrow just start using some files with your students, please feel free to check out our website, education.ti.com, and look at the building concepts material. We're really excited to have the T-Cubed International Conference coming to San Antonio in just a few weeks, March 2nd through the 4th. It's a great place to meet people like Michelle and Sam, to learn from them, and frankly just to be around other like-minded educators that feel the same way you do about teaching and learning. We really hope that you'll be joining us at the T-Cubed International Conference, and as we mentioned earlier, tonight we're giving away for one lucky winner a conference registration for 2, and tonight's lucky winner is Tuba Dundar. So Tuba, congratulations. We really hope to see Tuba as well as everyone else at the T-Cubed International Conference, again, coming up in just a few short weeks. To receive a certificate of attendance, go ahead and click that link in the chat window. Also, this is also listed as a link to the documents that were used tonight by Michelle and Sam. And if you happen to miss these links, or maybe they're not working for you for one reason or another, have no fear. You'll automatically get a follow-up email in a couple days. And in that follow-up email will be a link to the recording, a link to the certificate, as well as a link to the documents. And if you happen to watch this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Thanks so much, Sam and Michelle, for everything you shared tonight. I think a lot of people can agree that there was some really great comments and discussions in the chat window, which was really great to see. So thanks so much for making us think. I really appreciate it.
My pleasure. Enjoyed it.
Thanks for having us.
Thanks again, everyone. Really hope to see you back online real soon. Have a great night.